All right, so you can see my screen? Both of you?
Yes, sir.
Okay. Am I audible?
Yeah.
Great. So let's continue from where we left off. I think I was doing the application of integration to geometry, and we have to start today's session with volume, right?
Yeah.
Volume. Now, under volume, we are going to study many types of volumes being generated. Okay, like volume of solids with known cross-section area. We are going to study solids produced by revolutions. Okay, um, we are going to study how we can find the area through washer method. Okay, washer. So these three types of volumes we'll be studying today. So let me start with the first case where we are going to study volume of solids with known cross-section area. Volume of solids with known cross-section area. Okay. Now, what do you mean by volume of solids with known cross-section area? See, let's say I take an example. I take a very simple case. I may not be very good in my 3D diagram, but I'll try my best to make one. So let's say we have XYZ axis is like this. Okay. Fine. Okay. So now I've been given that this solid is based on a fixed cross-section area. Let's say this is the cross-section area on which the solid is fixed. Now this area can be anything. You may be given the curve like a circle or an ellipse or whatever. Okay. And you would be told that the solid that you're going to get is basically a solid which has got a fixed cross-section area. For example, they may tell you that it's a square like this. Because I'm just taking a very small section so that you are able to understand. Okay. I'm just taking a part of this curve. So this cross-section area is known to us, and they would give they would give you the, let's say I take a small thickness dx. This is your small thickness dx. Okay, this cross-section area is fixed for us. Okay, that means let me call this as A. Correct. So if I have to find the volume of the solid which is kept on this surface, this is a base surface, you can call it as a surface on which that cross-section area has been kept. Okay. It may be like, let me take a simple example. Let's say there is a circle like this and you are making a cuboid structure stand on it like this. Getting the point? Yeah. So on this entire surface, this small cubes like this are standing, or cuboids are standing. Right? This is a 3D structure. Yeah, this is your z-axis. You may call it. This may be your y-axis. This may be your x-axis, like that. X-axis. This is your y-axis. Okay. So this surface area would be given to you, A, and this thickness since it is taken along the x-axis, you can say this thickness is your dx. Correct? And you're trying to find out the volume of this entire structure which has been laid on the base of this circle. Okay. Then it's very obvious that for a regular structure like this, the volume dV would be nothing but a dx. This area given to us into the differential thickness along the x-axis. And this is what we need to integrate from a given value x equal to a to some value x equal to b. Okay. Let me give you an example. Let me give you the same example of this question. Let's say a solid has, listen to this question, a solid has its base on the circle x square plus y square is equal to 9. Okay. And all cross sections parallel to the x-axis are squares. And all cross sections parallel to the x-axis are squares. Okay. Fine. Find the volume of the solid. Find the volume of the solid. So what it is given? It is given that this is A is a square surface. Correct? And its extremities are on this circle, and this circle is x square plus y square is equal to 9 circle. Right? I made it flat because it is lying on the xy plane. Okay, hope you can imagine it. It's a flat surface. Okay, because it's in 3D. Now, how do I find this area? Now, first of all, at a distance x, okay, let me reach this point. So this point, let's say I call it as x comma y. So this point will also be x comma minus y.
Yeah.
Hope you are able to visualize it.
Yes, sir.
Okay. So this square will have its length as 2y.
Right.
So what will be the area of the square? Area of the square will be 2y square.
4y square.
4y square, correct. So can I say the differential volume would be a dx, that is 4y square dx?
Yeah.
Okay. So that would be the volume void, or you can say a small kind of you must have seen some match boxes, right? The matchbox is actually seen over here, right? Now here we know that since we are integrating with respect to x and I have a y over here, and xy are connected by this relation.
So you can change y square as 9 minus x square.
Absolutely. So I will change that, and I would write it as 4 9 minus x square dx. Correct? Correct?
Yeah.
Now tell me, from where to where should I integrate it? I have to integrate it from
0 to x.
No, this would be minus 3
x
point.
to x.
Yeah, x here will be minus 3, x here will be plus 3. So in order to find the volume, I need to integrate this from minus 3 to 3.
So basically across the entire axis.
Yeah, or you can say
Diameter.
you can say across the diameter. So you can say 2 times 0 to 3, 4 times 9 minus x square dx. Okay, can we find this quickly? So 8 times integration of 9 is 9x minus x cubed by 3.
2 by 3.
So that's going to be 27 minus c square is 9. Correct? That's going to be 18 into 8. That's 144. 144 square. Cubic units, in fact. Okay.
Okay.
Cubic units. Is that fine? How it works?
Yes, sir.
Okay. Let's take another example. The base of a solid is a circle of radius a. The base of a solid is a circle of
Sir, in
radius
the
a.
previous question, you said that it should be parallel to the x-axis, right?
Yeah, the
But
cross
haven't
section.
you done perpendicular to the x-axis?
No, the cross section is done in such a way that the pieces that you are making, it is going along the x-axis.
Okay.
Okay. So the base of a solid is a circle of radius a. Okay. And every plane section perpendicular to a diameter is a square. And every plane section perpendicular to the diameter is a square. Okay. Then the volume of the solid is option A, 8 by 3 a cube. Option B, 2 pi a cube. Option C, 4 pi a cube. Option D, 16 by 3 a cube. Option E, 8 pi by 3 a cube. Now I know looking at it only you'll tell the answer, but do it once again just for your own benefit. The answer is D actually, because if you see your A was 9 in the 3 in the previous case, right? So which of them gives 144? Only this can give 144, right?
Yeah.
Okay, so taking a clue from the previous example, you can always mark the answer. But let's say you are doing it, assume it as if you're doing it for the first time. So let's say this is your circle of radius A. And you are making thin cross section area like this. This is your dx. Okay, so and this plane that you have made, this plane is perpendicular to the diameter. The diameter and the plane are perpendicular. That means if the plane is like this, diameter is passing. Now you may assume the equation. You may assume the equation, anything that you want, x square plus y square is equal to a square. Yeah, so what will be the area of the square? Area of the square would be
X.
Again 4y square.
Yeah.
Correct?
Yeah, which is 4 into
dv will be 4y square dx. And y square would be a square minus square.
Minus x.
So 4a square minus x square dx.
X square dx.
Okay.
Yeah.
Integrate both sides from minus a to a. Right? Which you can also write it as twice 0 to a.
Correct.
Right? Let's quickly evaluate this. This will become 8 times
A cube by 3 minus
a square x minus x cube by 3.
Square x minus x cube by 3.
So for dv, why did you put the limits as minus a to a for that?
Because x square plus y square.
No, but for dv, I mean, I get it. For the other side, you have to put, but why for dv, you have put minus a to a?
Okay, so you can just put anything you want there, but let's say You don't have to put over here actually, because
Yeah.
you know that it's going from the
It's
volume will be
becoming
0
positive.
here actually. The volume will become 0 here. So it's actually starting from this position. The volume will be going from 0 to 0 in this case actually. So you don't need to write that actually. You can directly say V is equal to this.
Okay.
Okay. So this will become a cube minus a cube by 3. So that becomes 2a cube by 3 into 8. So 16a cube by 3. Is that fine?
Yes, sir.
Aditya, clear?
Yeah.
Let's take another one. The base of a solid is the region bounded by the parabola. The base of a solid is the region bounded by the parabola x square is equal to 8y, and the line y is equal to 4. And each plane section perpendicular to the y-axis, each plane section perpendicular to the y-axis is an equilateral triangle. Is an equilateral triangle.
That's 3 by 4, root 3 by 4 a square. Right?
Yeah. Okay. The volume of the solid is option A 64 root 3 by 3. Option B 64 root 3. Option D 32 root 3. Option D is 32. Option E is 32 root 3 by 3. Make a rough diagram if you can.
So it will be like a semicircle. The region.
Just try making the diagram, both of you, on your respective notebooks. X square is equal to 8y will be having its axis along the y-axis, right?
Yeah. Yeah.
Okay, so and perpendicular to that, you are making a cross-section
Right.
area which is that of a triangle. I've tried my best to show a triangle. Hope you can visualize it. Right?
Yes, sir.
And this thickness here is your dy thickness. Okay. Yeah. So first tell me the expression for A. What would be this surface area? Let's say this surface.
Root 3 by 4 a square.
Root 3. Yeah. Root 3.
Root 3 by 4 a square.
So what is A?
2y. Root 3 by 4 of 2y whole square. Which is root 3 y square.
Why is it 2 pi?
The same reasoning that you
It's
used.
2y or 2x?
2x, sorry, 2x.
2x.
So
Yeah.
root 3, so it'll be root 3x square. The 4 will get cancelled.
Absolutely correct, Aditya. Okay. So dv would be what, Shreya?
So dv will be root 3 x square dy.
dy.
And then now you integrate.
And x square is what?
So x square is equal to 8y. So you write root 3 dy 8y.
Okay. So when you integrate this, from where to where will you integrate it?
You
0 to
4. 0 to 4 and then 8 root 3 y.
Correct. It will be 8 root 3
Root 3 y square by 2
0 to 4.
in 0 4 to 4. 4
Okay,
root 3
so
y
I think
square.
it's 64 root 3 if I'm not wrong.
Yeah.
So option number B is the right option. Getting the idea how to do this. So let's say we take one more. Okay.
So can you go back 1 second?
Oh, I'm so sorry. Yeah.
Wait, so why did dv become root 3x squared dy?
Because your plane has been made perpendicular to the y-axis.
Okay, yeah, never mind.
Yes, sir.
Done? Aditya, fine? Can I go to the next slide? Okay. Sure, we'll take another one. The base of a solid is the region bounded by y is equal to e to the power minus x, the x-axis, the y-axis, and x equal to 1 line. So there is a base. Base is made up of this curve, okay, the x-axis, the y-axis, and a line x equal to 1. Okay, this constitutes the base. This is your base. Okay. Each cross section perpendicular to the x-axis. Each cross section perpendicular to the x-axis is a square. Okay. Then the volume of the solid generated is option A, e square by 2. Option B, e square minus 1. Option C, 1 minus 1 upon e square. Option D, e square minus 1 by 2. And option E is half of 1 minus 1 by e square.
So what's the graph of e to the power minus?
Minus x.
Okay. E to the power minus x graph. I'm just drawing it on a y and x axis. It's going to be like this. Cutting here at 0, 1. But when you're drawing in a 3D plane, please be careful how to represent it. First you try, then I'll tell you how to make it. Just draw the diagram and be ready. Assume this, follow this. This is Z. This is, let's say,
X-axis.
X. And this is, let's say, Y. Drawn. If I tell you, how will it look?
So I drew.
Draw.
No, I drew it. I mean.
Aditya, drawn?
Yeah.
Okay.
It's weird.
Just check.
It's like sleeping.
Correct?
Yeah. That's 0.
This point will be 0, 1. Correct? Actually 0, 1, 0, right? Okay.
Yeah, 0.
X equal to 1 would be this line. Correct? So your base is kept on this surface, which I'm showing with white, okay? Okay? See?
Yeah.
Okay. Now your cross-section area is made parallel to the x-axis. So you are making cross-section area like this. Correct?
Yes, sir.
This is a square. This is always a square. You can draw well, yeah. Good. Yeah. Try it out. What is the thickness of this square? This thickness is how much?
1
Dx.
dx.
So first tell me A. Once we know A, we can always multiply with dx and integrate it from 0 to 1.
Will it be like 0.5?
Sorry?
Will it be like 0.5?
0.5.
Yeah.
I think it's xy.
What is the area of this square surface?
A square.
X into y. Oh, square. So x square.
A square. Oh, no, no. Yeah. Okay.
Y.
Y
It will be
square.
y square.
Y square.
Yeah. And y square is e to the power x. Y square is e to the power minus x, right? So it will be this,
E to the
correct?
power minus 2.
So dv will be this.
E to the power minus 2x
So
dx.
v will be integration from 0 to 1. Done.
Which is
Right? Which is half 1 minus 1 by e square. Which option is matching? Half 1 minus by e square. Option E.
okay. So one more, sir.
So once you could you go to the right?
I was dragging it up here. Cool? Got it?
Yes, sir.
Yeah.
All right. So now we are going to start talking about volumes of solids of revolution.
So can we do one more, sir? One last.
Okay, let me check out. I think we actually covered the entire sheets problem also. Okay. Take.
Yeah, so you can go. You can. It's okay. You can do that.
I'll send you
It's
the
okay, fine then.
assignment. Yeah, okay. Second is volume of solids of revolution. Okay. So many times what happens is that you may be given a curve. Okay, let's say the curve is like this. I'm just drawing an arbitrary curve. So let's say the curve is like this. Okay. Fine. Now this curve, let's say I rotate this curve about the x-axis. So I rotate this thing about the x-axis. So you can imagine it's rotated like this. So this entire thing is rotated about, or you say revolved around the x-axis. Correct? If I'm not wrong,
Yeah.
you'll see a surface like this
You
getting
get a
generated.
3D figure.
Yeah, something like this will be getting generated. Correct?
Yeah.
Yes or no? Now
Yeah.
this volume I want, the entire volume I want. Imagine it to be a 3D figure. This is a 3D figure. Okay, I'll not be able to show it on a 2D. But think this area is rotated about the x-axis, so it will swap a volume. That volume we have to find out. Understood the question now?
Yes, sir.
Okay. Now, So what we do is, in those cases, we consider this volume to be made up of very small disks.
Yeah.
Okay. So basically, if you rotate this disk, it'll be if you rotate this particular area, it would look like a disk like this.
Yeah.
Correct. So think as if it has been chopped into small disks. You understand a disk, right?
Yes, sir.
The the cross section area, top view is this, and the side view is this. This is a disk. Okay. You can imagine it
Yes.
to be like this.
Yeah.
Yes, sir. We got it.
Yeah, disk. Okay. Oh, you must have seen a disk in physics also. You must be breaking into disks. Correct.
Yes, sir.
Now, what is the volume of this small disk, which I am calling as dV? So you would say, sir, for that I need the radius of the disk. So can I say this will behave as the radius of the disk? So
Right.
say pi r square, and this thickness would be the height. It's actually a cylinder. You can think it to be a miniature cylinder. Correct.
Mm.
What is the volume of a cylinder? Pi r square into
Square
h. Correct.
Yeah.
So pi r square is the volume of a cylinder. So in the same way, the disk is a thin cylinder. So pi r square dx. Now who's behaving as r here? Let's say at a distance x you are. What is r then? R is basically the y coordinate at that point, right?
Yeah.
So you can actually write y square dx also. Okay. And in y, you can substitute your f of x given to you in the question. Understood?
Yeah.
And to get this
Yeah.
volume, you integrate it from this value, let's say a, to this value, let's say b, and you get your answer. Is that fine?
Yes, sir.
Okay. Is the idea clear how it works?
Yeah.
Yeah.
Acha, if I ask you that you have a curve like this, okay? Okay.
Mm.
Let's say this is y equal to a till y equal to b, and you rotate this about the y axis. Okay.
Mm-hmm.
You will get a very bad.
Instead of the y coordinate, you can take the x coordinate.
Yeah. Now, yeah. Earlier it was x coordinate, x axis. Now I have taken it as a y, around the y axis. Now, what would be the expression that you would write, given that you have already been told that this function is x equal to fy?
So it'll be pi into f of y whole square dx, integral from a to b.
So basically, again, you break it up into small disks. This is a disk. Okay. Correct. This is the radius of the disk. Correct.
Yeah.
So its volume would be pi r square dy.
Pi x square.
Right. Oh, sorry. Pi.
Mm.
Yeah, pi r square, and now that
Pi.
r will be x actually. Correct.
Yeah. Yeah.
So that will be pi f of y square dy.
Yeah.
Correct. So for the volume, you just have to integrate this
From a to b.
from a to b. It will be pi f of y square dy. Understood?
Yes, sir.
Let's take questions. Let's say I have a semicircle of radius r like this. Okay.
Mm-hmm.
This is a semicircle of radius r. Now this is revolved around the x-axis. Find the volume of the surface generated. Of course, what type of a surface will be generated?
It will be a sphere.
A circle. It'll be a circle.
A sphere. A sphere will be
A sphere.
generated.
Yeah, sure.
So find the volume of the sphere generated by this. Assume this to be origin.
So is the answer 2 pi r cube by 3?
2 pi r cube by 3 will be wrong because it has to be 4 pi r cube, right? 4 pi r cube by 3, right?
Mm. So that's too bad.
See, again, when you revolve it, you get a sphere like this, correct?
Mm.
I'm just trying to draw a 3D structure. Okay, something of this kind. Correct. And you take a thin disc like this here of thickness.
dr.
This is your thickness. Okay. This is your x-axis. Okay. Okay, now what will be the r? So this is the thickness that you are rotating, right? This is half the disk, correct? So this r will be nothing but the y coordinate at this point. So let's say, don't write r because r is already used over here. That I will use in my limits. So let's say at a distance x, you have taken a small thickness dx, correct? So this point will be y.
Yeah.
So you'll say pi y square dx will be that small differential volume.
Yeah.
And for this sphere, you know that x square plus y square is r square. So y square is r square minus x square. Correct? So I can say volume is integral of this from minus r to r.
Minus r, yeah.
Right? So you can write it as twice from 0 to r also. So it will be 2 pi. Integration of this will be r square x. Integration of this will be x cube by 3 from 0 to r. So it's 2 pi r cube minus r cube by 3. That's 2 pi into 2 r cube by 3. That's 4 by 3 pi r cube. This will be the volume of the desired sphere.
Right.
Understood, Aditya?
Yes.
Yeah.
Okay. Now it may happen that you may be given a problem that where your revolution is not happening about x or the y axis. They may give you a different line altogether. For example, let's take this question.
Wait, so in the previous one, so what is the point of knowing it's a sphere and all? Like we just applied the same thing that we
you actually indirectly found the volume of a sphere by using this technique.
Okay, yeah, okay.
So you realize that a sphere would be generated if you rotated a semicircle about one of the axes.
Yeah. So in that case, you could have known the answer without doing the question.
I'm just trying to apply the technique to confirm it.
Yeah.
Question. Find the volume generated by rotating the region bounded by y is equal to x square, x is equal to 2, and y equal to 0 about x equal to 2 line. Let's try to imagine what region are they rotating? Which is this region that they are rotating? I'll just get some water and be back. Huh?
Yeah. So
He cut.
we got okay. Bro,
No, he
really-
didn't. He didn't.
Yeah, done.
He didn't. Ice. Easier.
Sir,
Yeah.
you get a really weird region. How will you
Isn't
know
it?
the
Isn't
area?
it like isn't it a triangle?
It's a triangle. That's
See,
some weird
let's say
region.
x equal to 2 line is this. Okay.
Yeah.
And y is equal to x square is a parabola like this.
Yes, it's sort of. Okay, not really a triangle.
Yeah.
It's
So
like
this
one.
this region, you're rotating about this line. So you would be getting something like this. I'm just making a rough diagram. This is the solid that you will be getting. This is the solid that you are getting. Okay. Understood how it works?
Yeah.
Yeah.
So you break this up into thin discs. Let's say this part of the disc will be not appearing as of now because you're rotating it, right?
Hmm.
Okay. So this disc, let's say thickness is dy. Okay. And this would be the radius. So how is the radius function of y?
So if you treat it as a triangle, then it
Why
will
will I take
be
it as a triangle? It's not a triangle.
Yeah, it's not.
When we have calculus, why do we need to use regular figures? Calculus was invented to take care of these conditions. Else you would have stick to our normal geometry only.
Mhm.
Okay, if I tell you this point is, let's say you go a distance of y up. Let's say this is y, and this is your x comma y point. Correct. What would be your radius? Tell me, in terms of x.
Oh,
Do you agree that the radius will actually be 2 minus x? So from here to where it's x, from
Yeah.
here to where it's 2. So this gap,
Yeah.
yes, 2 minus x.
2 minus x. Correct?
Yes.
So your disk would have a differential volume of pi r square dy. Correct?
Yes.
But the problem is I'm integrating with respect to y and I'm keeping an x over here. So I should change that x with root of y,
y is equal to x. Yeah.
because y is equal to x square. Simple. Now I have to integrate this from 0 till I reach the head. Now what will be the y at the head? 4.
Right.
Oh, you
No,
have
because
to
x
solve
y
them.
is x.
Yeah,
No, y is
because-
x squared.
Yeah, you have to actually solve them. So here x is 2, so y has to be 4.
Yeah.
Correct?
Mm. Yes, sir.
Now evaluate this and tell me the result.
So you get some
We
weird
4 pi y
minus.
square by 2 minus 4y to the power 3 by 2 by 3.
Simplify it and tell. Put the values and all and tell me the final answer.
It's some hectic.
So the answer is 4 pi.
No. Okay, you are integrating this.
Just a sec.
So I'm getting something like 52 pi plus 24 pi. Oh no.
So I did the same. I took the 4 outside for some reason. I don't know why.
Oh, okay. So you'll get 8 pi by 3. Fine?
Yeah.
Let's take more questions. At least 3 questions we'll do. First question is, all the questions follow the same instruction. The region whose boundaries are given is rotated about the line indicated. Find the volume of the solid generated. So the region is bounded by this, almost similar to what we did. And this is rotated about the x-axis.
Oh.
Make the diagram. Make the diagram first.
It's the same figure, but it's not this time. It will form a different 3D figure.
This is rotated about the x-axis. So you'll get something like this.
Yeah.
So when you break it up into thin discs,
Wait, so do you take your R as vertical? Yeah.
Hmm.
So you will take R as 4 minus y now, right?
4 minus y, yeah.
I don't know anything. You just do and tell me, because if I keep giving hint level, then it's okay to make a mistake. I'm fine with that. Imagine your discs. What is the disc that you're going to make over here? Yeah, any idea?
Just a sec.
For 1 second.
So is it 176 pi by 3?
No. Sure,
So-
done.
So 1 second.
So is it close to that?
No. This is a differential volume, right?
Yeah.
So if you replace the y with x
Sir,
square,
I got 384 pi by 15. Is that really far?
15.
Yeah.
I got 176 pi by
I'm
3.
surprised you just had to do this.
That's exactly what I did. Oh, what? Wait.
Wait, why is it from 0 to 2?
Yeah, it's from 0 to 2, exactly.
Oh, right, shit. Because
But,
it's around.
um,
Oh no. Oh no.
sir, isn't it pi 4 minus x square the whole square?
X square, the whole square is x4.
No. Isn't r 4 minus y?
R is y coordinate here.
Exactly. So, but isn't it 4 minus y?
Why
Whole
will it
thing.
be, why will it be 4 minus y? Where is that 4 coming up from?
So from the meeting point of the.
Your disk is like this, no Shreya? Disk will have this as the radius. Y will be your radius actually, right? So at a distance x, when you take a thickness dx, the y coordinate there will act as the radius.
So then why for the previous question you
Exactly.
didn't write x?
So the
Why
previous
you
one,
wrote
didn't
2
we just
minus x?
Yeah, why didn't we make it this way? Like,
Stop following the previous problem to solve the next problem. You are in grade 12 now.
no, I'm just like, no, like,
That's
how is this
stupidity
different?
to follow the previous problem to solve the next problem. There's no typification. Since I did it in the previous, there the rotation was happening around this line. This thing is the same situation here. Here it is revolving around this line. How can you follow the previous problem to solve a new problem? Just because I did a problem like this, every problem will be following the same way. Apply your mind. Your radius, your disk is created along the x-axis. This is your disk which is created like this. This is your x-axis, correct? And you're breaking this disk, small disk for this zone. This your small disk you are adding up till you reach this point. Till you reach this last point. So it's like circular disks like this which you are collectively adding. That creates this surface. See what is your
So then,
radius.
but honestly, so why did you then? Why did you take 2 minus x in the previous question? Just asking.
That's
Why
right.
did you do that?
Because it's rotated about the x equal to line, not the x-axis.
So
So what? That's
So that-
everything.
It's
Your
with
disks
regard-
are created like this, Shreya. Understood? So this radius will depend upon the distance on this line. So there's a disk like this created. There's a disk like this created. There's a disk like this created. And it goes all the way till the top.
yes, sir, got it.
So the radius, this will be your radius from here to here. So at a distance x, your thickness left, the radius will be 2 minus x here.
Yes, sir, got it.
Visualize it, you'll get all your answers.
Yes.
Okay, so let's take another one. Next is
Another question.
y is equal to x square and y is equal to 4. Okay, this is the curve bounded between these two, right? And the rotation is about y equal to 4 line. Make the diagram first.
Okay.
So it'll be like a quadrant. Sorry.
Y equal to x square is like this.
Yeah.
Y is equal to 4 is somewhere.
Yeah.
I'm giving you 4 to 5 minutes. Solve it correctly. Don't make any mistake. Okay. Hope you're able to imagine how that surface would be. And hope you're able to cut it into thin discs.
Yes, sir.
The line of rotation will always be the center of all the discs that you're breaking that particular solid into. Just remember that.
So is the answer 8 pi?
No. Aditya, you are my only hope now.
Just a sec. So 2 to the power 3 by 2 is just 2 root 2, right?
Yeah. So before I forget, tomorrow, what time do you want the class?
So like evening would be good.
Yeah, evening only because morning.
Evening I have a class.
Morning I have a class.
So I got some weird answer. I don't know.
Preferably if you keep it at around 7 to 8 or 8 to 9, that would be
So
fine.
4 to 6 I have a test and 8 to 10 I have class.
What class?
I have physics.
In the night?
Yeah.
Okay. Yeah, okay, we can do like 7 to
4
8.
to 6 is
something
test.
like
Okay. 4 to
6 to
6
10.
Oh, right.
and 8 to 10.
8 to 10, okay.
That
8
will
to
be
10
hard for me. I'll be going to the center, so it'll be hard for me to
Okay.
have classes anywhere between 6 and 8.
Okay.
Can you keep it before that?
So we can have it in
Afternoon.
No, but my classes
so
will
afternoon.
be
I
till 2 o'clock.
mostly won't be home.
Okay, never mind. We'll keep it on Tuesday then. Never mind.
Yeah. So my answer is weird. It's 102 minus 32 root 3 by 3 pi.
My God, wait. Okay, so do you realize that if I choose a disk cross section, this would be the disk which is getting rotated. So I'm not drawing this part of it because it is only created when it is rotated. So this would act as the radius.
Yeah.
Correct. Now see, let's say at a distance x, you choose this thickness dx. This is your thickness dx. Correct? Now you reach a point x comma y over here.
Yeah.
Of course, x and y are related by this relation. But as of now,
So
if I ask you, what would be this length then?
4 minus 1.
If this is y and this
4 minus
entire
1.
thing is
4
4,
minus 1.
r is 4 minus y. Undoubtedly, both of you would have got this.
Yeah.
Yeah.
So pi r square
4
dx.
minus-
This would be the expression.
4 minus root x whole square.
Correct. So this will be pi 4 minus x square whole square dx. This would be.
Oh no, so that's my mistake. So I took it as root x. I don't know why. I made it. Yeah, I think I would have got it.
Now x will go from which point to which point? What will be the x here?
It will be from 0 to 4.
This will be 2. Because when y is 4, x has to be 2, my dear.
Yeah, so I did that also.
So it will be 0 to 2, but that is not sufficient. That will only give you half this surface. That will only give
2
you this part.
times. 2 times 0 to 2.
Wait, so
This is your
So let me tell you the answer. Wait.
Yeah, now tell me the answer.
So mine went completely wrong. There's no chance.
So then you're formulating a wrong image in your mind then. You're
So
not
I
able
did
to
everything
visualize it.
except I made it root x.
I took the discs horizontal.
And given that you have done moment of inertia and all, Shreya, you should be able to do it faster because you had calculated the moment of inertia of any surface, any kind of solid.
And don't.
So 16 minus 8x square plus x to the power 4.
Some weird fraction. 350 plus super 5 exactly. It will take 15 LCM. Yeah, exactly. So is it one second.
It's 512 pi by 15.
So is it 512 pi by 3? Yeah.
Pi by 15. Chalo, I'll give you one more opportunity to rectify your mistake.
Yes, sir.
Okay, Shreya is all charged up to get this right.
Yes.
So there's an arc. There's an arc which follows this equation. Okay. So find the area, find the volume of the solid generated by rotating the region between the arc y is equal to sine x. This is the region which you are rotating about. X-axis. Consider this to be the part which you're rotating. This is the solid.
Mm-hmm.
Pretty easy.
Yeah.
What happened?
So 2 seconds. Almost done.
Yeah.
So I don't think this is right. I don't know.
What is the answer you got?
Pi by 2 into pi minus sine 2x by 2.
How can x appear in your answer? Are you not putting the
Sine
limits?
2 pi by 2.
Sine 2 pi by 2 is 0.
So pi square by 2.
Answer is pi square by 2.
Yeah.
That's correct.
Oh, finally. Oh God.
Aditya?
So I'm not sure how to do that.
See, again, same thing. If you take at a distance x, you take a disk of thickness d. So this will act as your radius.
Yeah. Yeah.
So y coordinate there will act as a radius. So y is your sine. So it will be sine x square dx. This will be your differential volume.
Oh, that's it. Cool.
Yeah. And you have to integrate this from 0 to pi. This is what we are supposed to do. That's it. Story over.
Yeah, I got the 0.
So for sine square, you have to write it as 1 minus
1
cos.
minus cos 2x by 2.
That's pi by 2. Integral of sine to cos 2x will be sine 2x by 2, 0 to pi. So it's pi by 2 pi minus sine 2 pi by 0 is 0. So your answer will be pi square by 2. Understood?
Yeah.
Do you want one more or is it sufficient?
One more.
No.
Okay. But I'm happy this time Shreya got it right without any problem. So let's have one more.
So, once could you go back to the previous one? Just.
Oh, yeah.
Yeah. Yeah. Yeah. It's fine.
Okay. Okay, so next question is, a trapezoid with vertices 2, 0, 2, 2, 4, 0, 4, 4. Okay.
Hmm.
And this is rotated about the x-axis. What's the volume of revolution generated?
Hmm.
It's a rectangle, basically.
Not a rectangle, it's trapezium.
Oh, right. For come off.
This guy is rotated about x-axis.
So how will you find the relation between x and y in this?
You tell me. One more time, or should I do it?
So 2 cents.
Yeah. Aditya, what about you?
So confused about like how do you get a x value from y?
Are you able to imagine that solid surface?
Yeah.
It would be somewhat like this.
Mm.
Yeah.
Basically, this is made from a trapezium. This is a trapezium part. This is a disc. Taking a lot of time.
So I didn't get it.
So this is y, and this line is y equal to x line.
Yeah.
Yeah.
So it's pi x square dx integrated from 2 to 4 over story over. This is your volume.
Oh?
Oh,
No.
because y is equal to x. So, but oh shit.
Oh my god.
I'm not very happy the way you have responded to this concept. Answer is 56 pi by 3. This is the fifth example, I guess, I have given for this question. Okay. Let me give you another one then. Again, I'll go back to the same curve. Y is equal to x square. Okay.
Mm.
Y-axis and y equal to 4 line. So this is the region bounded between these 3 lines, and this is rotated about y-axis.
So you can take either of the regions, right? It will not make a difference.
Yeah, the same thing is rotated about y-axis. That means it will be like a vessel like this. So this is the region which is rotated. This region is rotated like this. So this solid is generated.
Yes.
Okay.
Yeah. So the answer is 8 pi.
8 pi. What do you say, Aditya?
Yes, sir.
Eight pi is correct. So this is the disk that you will form, right? This is
Yeah.
what you will rotate.
Yeah, 8 pi.
Okay, so this is the radius. So again, at a distance of y, you will take a thin. At a distance of y, you will take a thin strip of dy. Okay. So your area will be pi r square dy.
Yeah.
Correct. Now what is r here? R is going to be the x coordinate at that point. So x is root of y. Correct.
Yeah.
So it will be pi y dy.
Y,
Correct?
Yeah.
y dy, which is y square by
And it will be integrated from 0 to 4.
4.
So that will be pi y square by 2 from 0 to 4. That's going to be 8.
8 pi.
Yeah.
Okay.
Yeah.
Now the third scenario is the washer method. Now this washer method is not the name of a mathematician. Okay. Do you realize that whenever you put a screw, you put a washer in front of it? Whenever you put a screw, you put a very thin disc like this plate, and then tighten the screw, right?
Yeah.
Right. So that thin screw is actually called the washer.
Oh.
Okay. You may have seen in your cycles when you are putting some screw, they would do a washer before that. Okay, now what is this washer method? This washer method is basically used when, let's say you have two curves. I'll give you a curve like this and there's another curve like this. Let's say. Okay. Now, if this curve I'm rotating about, let's say, x-axis. Okay, so this area, if I'm rotating about x-axis, right, it's like saying that you are taking a thin area like this yellow area, and you're rotating this area about the x-axis. That means you are creating a surface of this nature. Correct?
Okay.
Right.
Yeah.
So it creates a thin disc like this. You can say a kind of a hollow cylinder you are creating.
Okay. Yeah.
Yeah.
Are you getting this point?
Yeah.
Yes, sir.
So this thickness is basically your thickness of the cylinder, and you're rotating it about like this.
So it's
Getting the-
volume of the bigger cylinder minus.
Yeah,
volume.
so it actually generates a washer kind of a surface. So this appears to be like a washer.
Right.
Okay. Now I will, if you have understood this concept, can I directly take a question?
Yeah.
And let's see whether you're able to get that.
Okay.
Find the volume obtained when the region. Find the volume obtained when the region bounded by y equal to x square and y is equal to 2x is revolved around the x-axis. Is revolved around x-axis. Okay. I will do it for you, and then I'll give you a next problem. This is not a very important concept, by the way. Okay, but you may never rule out any question from this. So let's say this is y equal to 2x line.
Yes.
And let's say this is y square is equal to 4x. Okay. Now this is the part which is revolved. This, you see this section?
Yeah.
This section?
Mm.
This guy is revolved. So basically it's going to create a
Yeah.
surface like this. Okay, so this is a solid that you are getting. You have to find the volume of this solid. So basically what you can do is you can assume that there is a hollow washer like this going around about it. Okay, this hollow washer is going about it. This is the hollow washer that you are making. Okay, and you're trying to find the volume of this, integrate these small washers to get the final answer. So think as if this is the thickness of the washer. Okay, and try and tell me if you have a cylinder like this, which is hollow from inside, like this. What do you do to get the volume of the cylinder?
Area of the larger cylinder, volume of the larger cylinder minus volume.
Let me show you the top view. This is the
So
top
basically
view.
pi, the radius of the
Let's say
larger
this is
sphere.
height. Let's say this is the height. This radius is from here to here, it's R1. And from here to here, it's R2. How do you write the volume of this?
So pi
Pi
R2
R2
square
square
minus pi R.
minus pi R2 square minus R1 square.
Is that fine?
Yeah.
Okay. Now think that when you are creating a washer like this, okay, from here to here, this is the outer radius, let's say R2. From here to here, this is the inner radius R1. Correct?
Yeah.
And this height that we are talking about is your dx.
Yeah.
Okay?
Okay.
So can I say R1 will be, R2 will be the y coordinate of the upper curve?
Yeah.
Which will be x square?
Hmm.
R1 will be the y coordinate of the lower curve, which is
Correct.
2x. Correct. So I have to create a volume, then its volume would be pi r2 square minus r1 square dx.
Yeah.
And I have to integrate this from this value of x to this value of x.
Yeah.
So where will it meet? 0 it will meet, and you just compare. 2 it will meet.
So, but won't that give you an integration? Won't it give you the integral of volume?
No, this is pi r1 square r2 square r1 square and into height.
H. Exactly. So why is it like so? If you integrate that whole thing, won't it
of course.
won't you have to integrate left hand side also?
Yeah. Integral of this will only give me the volume, right? When you're adding.
No. So like you like on the right hand side, like you've written that v is equal to that. So if you and what you've done is you've integrated the right hand side. So don't you have to integrate the
So it is integrating the left hand side also. It's dv equal to that. Then he's integrated both sides.
No, but
dv is just this. dv is just this part without the integration part. This is dv.
Now he's integrated, it will become v.
The moment you integrate this will become v, and this will have this limit 0 to 2.
Yeah. Okay.
Yeah. So let's find it out. So pi x to the power 5 minus 4x cubed by 3. 0 to 2. So it will be pi 32 by 5
32
minus
by 5 minus
32 by 3. Oh, by the way, 2x will be up, na? No, this is 2x. I reversed it. So I'll get the negative of the answer. Sorry. So let me reverse this now. 32 by 3.
64 by 15.
So it's 32 pi you can take outside. So it's 2 by 15. So it's 64 by 15.
64 by 15.
I did a small mistake. 2x was up actually.
Yeah, so I was thinking. Yeah.
So
Okay.
R2 should have been 2x and R1 should have been x squared. But anyways, the idea is clear, right?
Yeah.
Okay. Now try this one.
Okay.
I will not do a lot of questions because this is not a very important concept. Find the volume of the solid generated when the region y is equal to x square, when the region bounded by these three, this is the region, when this is rotated about y-axis. Understood?
Yep.
So this region is rotated about y-axis. So it will be like a bowl which is having a parabola inside. So it looks like this from outside, but you have a parabola inside. Something like that. This will be the solid area. This is the hollow washer. I'm showing you the cross-section area, okay?
Okay.
Nowadays I'm doing a lot of coloring with my daughter also, so I'm enjoying doing this. This one will be your R1.
Yeah. So will R2 just be 2?
R2 will be 2, absolutely.
Yeah. R1 is root y, right?
R1 will be the x distance, right? Let's say the distance y.
It'll just be X. It'll just be Y, not root.
This length will be R1. So the x coordinate there. So that will just be x.
So won't it be X square? Because it's on the Y equal X square.
No, R1 will be x. But when you're using it in the
it's
volume,
on the Y equal to X square line, right?
that's fine. R1 will be x, but when you're using in the formula, you'll have to do R2 square minus R1 square. So automatically that will become x square only.
Yeah, no, I'm saying, isn't R2 itself isn't R1 itself X square?
No, because R1 is the x coordinate of that point. X coordinate is x coordinate. That's it. See, this is your R1 from here to here. Okay.
Yeah.
And till here, if you extend, this thing entire will be your R2. So R2 is this distance which you rightly said was 2.
It's true. Yeah.
R1 will be the x coordinate at that point. Let's say this is x comma y point.
Yeah.
So the x coordinate at this point will be R1. So R1 will be x.
So will the limits be from 0 to 4?
Absolutely correct. So it will go till this point. 0 to 4. This point will be 2 comma 4. So 0 to 4. R2 square is 2 square, which is 4. R1 square is x square. You just have to do this then.
So I don't.
No, got a negative.
So it'll be 64.
Okay.
So it'll be 16.
Get a negative.
Oh my god, wait. I have to integrate with respect to y, right? Why am I writing in terms of x? Sorry, I have to write in terms of y. Because the differential step is along y, no?
Yeah.
So this x square has to be made y.
So it'll be 4 minus y d.
Yeah, I'm sorry. Yeah. So it will be 5 4y minus y square by 2. 0 to 4. Now it will be 5 16 minus 8. This will be your answer. Is that fine?
Yeah.
So one last
Yes,
problem
sir.
I'll take on this, and then we'll move on to the arc lengths. The region bounded by
So generally when you have a irregular shape, you take Washer's method.
no washer is when you have two curves and the area between them is rotated. That's washer method.
Yeah.
When you have one of the curve as the x-axis or the y-axis, you take the disk method.
So, but in this one which you just gave, like we had the same thing, but we did this method also. Like the question that you just.
Because if this were rotated about this, you would have taken the disk method, right?
Yeah.
Now this this area is actually rotated like this, so there you will take a washer method, because that will
Yeah. Okay. Got it.
that will create a washer. As you can see, the washer
Yeah,
will be created in that case. In this case, a disk will be created. So you have to figure out what type of elementary volume is being created. Is it a disk which is created, or is it a washer which is created? Okay. Area bounded by y is equal to 3x minus x square and y equal to x is rotated about y axis. Find the volume of the solid generated. Sketch the curve first. Very important to sketch it correctly. Y equal to x is a line like this. That's right.
The 3x minus x square is a downward sloping.
Yeah, that's going to be a parabola like this.
Yeah.
Cutting at 0 and 3. So now this area that you see over here, this is rotated about y axis.
Okay.
So R2 will be x and R1 will be 3x minus x square.
Yeah. So your disc that your washer that will be created. Let's say I create a washer like this. This one will be your R1. This one will be your R2. Correct?
R2.
Because
Yeah.
it will be a washer created in this way. Correct?
Yes, sir.
This will be the washer created. Okay. Yeah. So at a distance of y, again take a thickness of the washer to be dy. So what will be R1 now? R1 will be the x at this point.
Yeah.
And R2 will be the x at this point. So x at this point, again you have to take, it will create a problem over here because
Yes.
you have a very bad equation in terms of y.
So I just rotated about the x-axis.
Okay, so this funda will not work because writing x in terms of y would be difficult. So now I will change my gear. See, now I'll undo this whole thing. What I'll do is, yeah. Now I will take a washer like this, and this I will rotate like this. So your washer will be now created like this. Correct?
Okay.
Now let's see whether you are able to solve this.
Wait, what's different between that and this?
There is a difference. What expression will you now write for the volume?
Same thing. Y R2 square minus R1 square into x. R2 being.
Yeah, what is R1, R2 in this case? That would create a problem.
So it gets interchanged.
What do you do, Shreya? Any idea?
Okay. Now you can. No, you still have to do in terms of y.
So I have a doubt in the previous one. Okay, I'll ask you after this.
If I say, if you cut this, okay, and open it up, how would it look like?
Can a rectangle.
It would look like a slab like this, correct?
Yeah.
Hinman, because this is what you rotated and created a disc like this.
Yeah.
Correct?
Yeah.
What will be the length of this?
The height. I mean the circumference.
Okay, let's say I'm this point coordinate I give you. Let's say I tell you that this point is x comma y2 and this point is x comma y1. Okay, now can you tell me that if I have a circular washer like this, what would be the length of this entire if I cut it open? So think as if there's a washer like this. Okay, and I cut it from here and open it up. It will look like this then.
Yeah.
Now, what would be the radius of this washer? The radius of this washer will be the x coordinate.
Yeah.
Correct. So this entire length will be 2 pi x or no?
Yes, sir.
Correct. What will be the height of this washer?
It will be
Y.
It will be the difference of the y and y2.
y2 minus y1.
Y2 minus y1. Correct. What will be the thickness of this washer?
Dx. Dy.
Hey, dx, no?
Oh, right. Dx.
Correct. So this, at a distance, this, you have taken a thickness of dx over here, right?
Yeah.
Correct. So if I have to write the expression for the volume, I would write it as 2 pi x y2 minus y1 dx. This is not easy to write because now I will write y2 of the parabola minus y1 of the curve, y1 of the line. Correct?
Yeah.
And this I will integrate. From where to where will I integrate?
0 to 3.
0 to this meeting point.
Yeah.
What is this meeting point? Simultaneously solve this. So x is equal to 3x minus x squared. So x squared is equal to 2x. So x will be 0 and 2. 0 is already accounted here. So this point has to be 2. Correct?
Yeah.
Yeah.
Yeah. So your answer will be volume is equal to, let me read this, volume is equal to 0 to 2. Is that fine?
Yes.
Yeah.
So let's solve this. Your answer will be 2 pi. This will be 2x square minus x cube integral from 0 to 2. That will be 2 pi 2x cube by 3 minus x4 by 4 0 to 2. So 2 pi 16 by 3 minus 16 by 4. So if I'm not wrong, it will be 32 pi 1 by 12. So that's 8 pi by 3. Cubic units. Is that fine?
Yes, sir.
By the way, this is called the shell method of finding the volume. Shell method. This will not be asked in AP exam.
Oh.
So this is optional in case you're stuck somewhere and you have to use shell method. But mostly it will not be asked. Okay, now we are moving to the next part. Volume is all done. Okay, so now we are into the arc length. So arc length is basically where you are able to find out, let's say I give you a curve, y is equal to f of x. And I ask you, what is the length of the arc from here to here? That means this part. Of course, it's not a straightforward line that you can measure its length by using x2 minus x1 square, y2 minus y1 square and the root. It's actually a curve. So how do you find the length of this curve from a point x equal to a to point x equal to b? Okay. Now this comes from a very simple concept. See, if you have, let's say this arc. Okay. Now in this arc, basically what we do is, let me call this length, this entire length from here to here as ds. Right? So we use calculus to approximate it as a
Right triangle.
So basically your ds square is actually dx square plus dy square. For a very, very small segment, you can approximate it like this.
So I can't hear you.
So your voice is breaking.
So I'm saying for a very, very small segment, you can approximate it to be a triangle like this.
Yeah.
So this part, you can actually treat it like a small triangle like this.
Okay.
So ds is like your hypotenuse. I'm sorry, I should write dx over here. And dx and dy are like your sides of the triangle. Okay. So they'll always form a Pythagoras, always form a right angle triangle like this, or a Pythagorean triplet like this. Okay. So in light of this, you can say ds is under root of
dx square plus d.
Correct?
Yeah.
If you divide by dx here, that means inside you have to divide by dx square.
Dx square, yeah.
So that will make it 1 plus
1 plus dy by dx the whole
whole
square.
square. Okay. So if you bring a dx over here, you can actually find out s by integrating this. So your s will be from integration of this from a to b. Is that fine?
Yes,
so of course, y will be given. So you will be able to find dy by dx whole square expression. You just have to take the under root, integrate with respect to x. By the way, let's say they had given you y instead of x. Let's say they give you y is equal to c till y equal to d. Then you don't have to convert into x. You can directly change this formula and say under root of, instead of dividing by dx, you will divide by dy.
Divide by dy.
So it will become
so
1
plus
di
1 plus dx by dy whole square
with respect to y from c to d. Correct?
Yeah.
And many times they're very clever. They will give you neither in x nor in y. They'll give you in parametric form.
Then you convert it to dy.
Yeah. No need to convert. They'll give you like this. Then what do? Now either you can use this formula or this formula. So you can integrate it like this under root of. You can say, right? Let me write it over here. Dy by dt whole square. Dx by dt whole square. With respect to dt, you will integrate, and now you have to use the parameter of t. Let's say t is from p to q. Okay, that depends upon the question being asked. So I will try to take an example of each type. Is this concept clear to you? So just remember these formulas. This one. This one and this one. Note it down if you want to note it down somewhere. So remember the differential elements here. Here it is dy. Here it is dx.
It's a parametric. Why does it become dy by dt whole square plus dx by dt whole square?
Same thing. When you say dy in this case, it will be f dash t dt, correct?
Okay.
And dx will be g dash t dt. Correct? So when you square and add, dt will come out. Dy by dt means f dash t. Dx by dt means g dash t. So use this formula again. This formula.
Yeah, okay.
So it will become like this. It will become f dash t square dt square.
Plus g
and g dash t square dt square. So when you take under root, this will become this. Okay, and you divide it by dt, so you can take dt outside. So integrate this. So dt will come out. So it will be f dash t square g dash t square dt will come out. Integrate from t value. T value should be kept over here, not any x value or y value. T from p to q. Let's take questions. Find the length to 3 decimal places of the arc of y is equal to x to the power 3 by 2 from x equal to 1 to x equal to 8. So since they have given on x, you would write it as?
First, with respect to dx.
Yes. So 1 plus dy by dx square. Whole thing integration with respect to dx from 1 to. Complete it and tell me the answer. Please calculate your answer to 3 dp.
Okay.
So what did you say?
3 decimal places.
3 decimal places. So y is this? What is dy by dx?
dy by dx
3 by
is
2 root x.
3 by 2 root x.
So dy by dx square will be what?
9 by 4 x.
So you have to integrate 1 plus 9
Plus
by
9
9
x
by
by
4x.
So this is reverse chain rule. So this
3
is 1.
by
1 plus
9 by 4 x
3 by 2 by 3 by
by 3 by
Divided by 9 by 4.
divided by
So it's 8 by 27. Yeah. When you put 8, you get 1 plus 70, 18.
2 by
1 plus
4,
18.
that's 18.
19.
19 to the power 3 by 2.
Yeah, there you go. Keep it.
That's why they asked you use a calculator here.
Yes, yeah.
19 to the power 1.5 minus this will be 13 by 4 to the power of 1.5.
Yeah.
How much is it coming out?
Mm.
They say it should come out to be 2.2 something.
Okay.
I mean, do you have a calculator? You can calculate it. 2.268.
Yeah.
No, sorry. They say it's 22.803. Okay. Anyways, the idea is clear, right? How it works.
Yeah.
Okay. One more I'll take with respect to y now. Find the length of the arc up to 3 decimal places of the curve x minus 2 square is equal to 4y cube from y equal to 1. Sorry, y equal to 0 to y equal to 1. So you can write it like this if you want.
So we.
Yeah. Correct?
So
Yeah. One, two, three.
it will be 10 to the power 1.5.
Yeah. Okay.
What is the answer that you get?
So approximately 2.22.
Yeah, they say 2.268. This was the answer.
But I'm getting a recurring decimal. 2.2.
Don't round off, okay?
No, I didn't. I go. Oh, okay, I did. Yeah. Okay.
Round off at the end when you get the final result.
Okay.
Aditya, is that fine?
Yeah.
Okay, one last question for today. The position x comma y of a particle at time t is given as x is equal to t square and y is equal to t cubed by 3 minus t. Why my t is floating up? Find the distance. Find the distance, not the displacement. Find the distance of the particle traveled between t equal to 1 and t equal to 2. So it's a distance. So it indicates that you have to find the arc length.
So you can also convert it to dy by dx or dx by dy and solve
You
using
can
the first two
eliminate.
equations.
Yeah, you can always eliminate your t, get directly in terms of x and y, and from there you can use the formula. But again, when you know it in terms of t, why to waste time?
Okay.
Unnecessary time will go into conversion.
Okay.
So it will be integral of t to the power 2 plus 1 whole square whole root from 1 to 2.
It will be integral of dx by dt whole square, which is 2t square.
2t.
Plus,
Yeah.
plus t square minus 1
Plus.
whole square, which is the same as t square plus 1 whole square.
Absolutely. This will be your distance. And the good thing about this expression is that even though it's under the
It's
root,
exactly
it's actually
perfect
t.
square.
It's a perfect.
That's what I said. It's t square plus 1 whole square.
Oh.
Yeah, it's a perfect square. Absolutely. So that's going to be integral from 1 to 2 of t square plus 1.
7.
Huh? How 7?
5 OT cube.
So it's 8 by 3 plus 2.
So it's 3.
No, it's not even that. So 8 by 3 minus 1 is 7 by 3. 7 by 3.
4 by 3. So it's 14 by 3 minus 4 by 3.
I'm just directly doing some calculation. Okay, anyways, yeah. 14
So
by
8
3
by 3 minus 1. So much plus 1. Yeah.
Okay. So Tuesday we are going to have a class. The timing I will let me know what time you are free on Tuesday, because again evening time would be suitable for me.
So Tuesday evening is fine.
Okay. So Tuesday I'll have to complete improper integrals with you. Okay, improper integrals is a small part left, and then we have to start.
You start differential equations.
No. Then we have to start with further application of integration.
Okay.
Okay, there are 2 chapters: application of integration, and another is further application of integration, which is motion along a line, motion along a plane curve.
Oh, same thing for differentiation, now integration.
Yeah.
So I have a doubt in the washroom method thing.
Yeah. Tell me.
So like if you want, you can go to this. Like, so the first question that you asked, like where we took like 2 curves, one was y equal x square and one was y equals to 2x. So like yeah.
I think it was
the one where you drew a screw. You can search for that. So board 7, I think.
it went quite up.
Board 12. Yeah, that one. So that one. Wait. I think a little more down.
Yeah.
No, Bob. Okay, yeah, this is the one. Yeah. So here we took R2 as x square and R1 as 2x because that's what the curves.
Yeah.
Like.
Yeah.
That's what the curves were. So, but then the next one, like I know I'm not comparing questions, and it's like I understand what's different between that.
Next one is 15th one.
Yeah, next question which you did.
Yeah.
Yeah. So over here, why did we take R1 as just x and not x square? Because in the previous one, we took it according to what the curve was, right? Like like at every point y, like at every point x, y would be equal to x square.
In the previous one, you actually had this surface, right? Like this.
Yeah.
Correct. So the radius will be this length, which is y, and this length, which is y. Correct. Y1 and y2. This will be your R1 and R2.
Yeah.
Here, this will x will be your R1 for this point, and x at this point will be your R2.
Yeah.
Yeah, so that's what we did. In previous question, it was y which was playing the role of R1 and R2.
Yeah, but you took R1 as just x.
In the previous question?
No, in this one, you took R1 as x and you took R2 as
2.
2. Yeah.
Yeah, because this point is x comma y point, right?
So but why can't you just take it as y is equal to x square? Also, okay, fine. Is it just fine to take R1 as root y? That would also be correct, right?
Of course. Yeah.
Okay.
That's what you had done, then. R1.
Yeah, I mean, you said it as like equal to x, so I got a bit confused. Yeah, so you can just take it as root y, right?
Yeah, root y. Okay, then. Thank you so much.
Okay.
Bye bye. Good
Thank
night.
you, sir. Bye. Good night.
Good night.